Okay, so these next problems that we're going to look at, they're the same general idea of what we've been doing, but it requires a little bit of setup. So these problems say, evaluate the expression given that the cosine of A is equal to 4 over 5 with 0 less than A less than pi over 2. And then that the sine of B is equal to negative 15 over 17 with 3 pi over 2 less than B less than 2 pi. So what we're doing is we're going back a little bit to where we had to set up and draw the triangles. Okay, so we're told where they're existing. Okay, so we have one in quadrant 1 and one in quadrant 2 or 4. I think that's 4. Yes. I was like, nope, this way. I always have to think about it.
Do you need your circles?
For these, no. Yeah, no, you don't.
After this problem, can we go back to the last one we did yesterday? I just had like one question.
Oh, let's do that first, and then this one?
Yes.
That here, yeah, I forgot about that. So, yeah.
So I was a little confused about, I think it's a little more up, like when we multiplied by 3 over 3.
Here?
Yes. I was confused like why.
Okay, so basically what we needed to do was we needed to have a common denominator to add these two things together on top, because I guess not that I technically couldn't have multiplied by like 1 plus the square root of 3 over 3, but that would have been a lot to like handle. So if we get, because like I guess that would have led us like all the way down here. So multiplying by that gives us the common denominator on the bottom and allows us to add the two things that are on top. Because I can't just add 1 plus root 3 over 3 without a common denominator. So what that allowed me to do was to rewrite it as basically a fraction on top and a fraction on the bottom, which led me to being able to do the keep, change, flip thing. And so, which cancels stuff to make it nicer, because it's a lot nicer to multiply this by 3 plus the square root of 3 than trying to multiply by 1 plus the square root of 3 over 3. Like, that's just going to get a little chaotic. And then you're still going to ultimately, because you're going to end up having radicals still, have to go back. So doing it early is very helpful in terms of reducing things to make your life easier going forward. Because we always want to get things as simple as possible to move forward in it.
Okay.
Does that kind of answer that question?
Yes.
Okay. And so then, I don't remember where we kind of got when the bell was ringing, but we got to here after we did the keep, change, flip, and we canceled. We had to multiply by the conjugate of the denominator because we can't have a radical left in the bottom. So we want to get that difference of squares on the bottom. So that's why we multiplied by the 3 plus the square root of 3. Then on the bottom, obviously, difference of squares, that's just 3 times 3 minus the square root of 3 times square root of 3, which gives you 3. So then on top, this is technically a perfect square trinomial because it's got the basically repeated factors. And so what I didn't write was that this is the middle step. I mean, the first and the last step were probably pretty obvious, but this middle step was really 3 times the square root of 3 and then the square root of 3 times 3 being added together to give you 6 square root of 3. And so then we had this here when it simplified, or very simplified, down to here. So then I think this is where the bell rang, actually, like right around here. So then what I did was I had to factor out a 6, because what I can't do is just cancel and be like, well, this is 2 and this is 1, because it's being added on top. So we have to take something completely out, which is what I did here. I took the 6 out and was left with 2 plus the square root of 3 over 6. And then I can reduce that, and then I'm just left with what was in parentheses.
Okay.
Does that kind of help? Because I know that we kind of rushed through that yesterday. So, yeah, thank you for reminding me to go back. Because these next ones follow the same process, but they're, well, I was going to say they're probably a little easier because they're just numbers being used. It's not like radicals and stuff like that. So there's less like algebra stuff that's going on inside of them.
It's
All right, so like I said, these ones give you this information, and we're going to be drawing the triangles. So the beauty of this is that when I draw these triangles for you, there's 6 problems that go with this, and they're all going to come from that. And when you get your test or your quiz, it's going to be the same triangles that are given to you, like the same information. So what my personal recommendation would be is obviously I'm going to draw them for you, and then we're going to use them to solve like 3 different problems. You can just use that if you want. Somebody's phone dinged. I don't care. It was random. Watch it be yours.
I know, that's going to be horrible with mine.
Anyways, so what my recommendation is, I'm going to draw them for you. We're going to use them drawn once for all the problems. I would say for you, when you get to your homework, even if you just, maybe not today, but when you go back to review for the quiz or the test, is go back and do it as if it's straight from the book, like you didn't already have it drawn for you. Because on the test, I will give you the same information, maybe changing numbers, but basically the same information, and you're going to have to go through and set them up and draw them yourself. So if you remember how to set them up, that's fine, but I think you should understand the process, because if you do, or say like in the review, you have a different problem or information given to you, you need to know how to set it up. So, anyways, so this is going to be a triangle A and a triangle B. Okay, so there's going to be 2 triangles that are getting drawn. So the first one I'm going to set up is from 0 to pi over 2. So this triangle is getting drawn here. And this angle is A. Okay. So cosine is what? Yep. So that's going to be 4 and 5. Now remember, you also have to watch the signs for these ones. Okay, now this one, obviously everything's positive in this quadrant, so we don't really have to worry about it. When we get to B, we'll have to check it and make sure we have things going. And if you were to have it in a different quadrant, you've got to make sure you have that going, or pay attention to the signs, which I think y'all were fine with when you did the problems before. But anyways, so now I need this other side, which if you know the Pythagorean triple, you can just answer the question. If not, we can solve it. 3. If you, why did I do that? That was weird. If you ever forget the mu alpha theta banner on the back, there's a triangle in the middle of the MAO. And if you count, the A has 3, the M has 4, and the O has 5. It's a 3, 4, 5 triangle. It's a Pythagorean triple.
Well, ain't that nifty?
Also, I need to talk to y'all about that before we're done today. So don't let me forget. So then let's go ahead and draw the other triangle. Leave a little bit of space to write a little something here, nothing big, just a little something. All right, so then this other triangle is getting drawn in this quadrant, again, touching the x-axis. So this is angle B. So B is what? Or, well, I should say sine of B is what?
-15/7.
So where is that going? That's what I'm trying to ask.
The
Words are not working.
okay.
Sorry.
Okay.
That was a very misleading question.
The -15 goes on the vertical one.
This one?
Yes.
17 goes on the hypotenuse.
Yep. And so remember, the hypotenuse can never be negative. And so then the other one, we're going to have to solve for because I don't know it off the top of my head. So it'll be a squared is equal to 17 squared plus 15 squared. And yes, I know it's a negative sign, but since it's getting squared, it doesn't matter. Oh, wait, minus. Hold. Minus, because it's C. This is C squared minus B squared. So then A is equal to the square root of that. Which y'all can just type in your calculator and get an answer.
389 minus 225.
And then you can take the square root of that.
Shut that down. 8.
Yeah. Oh, it is one of those triples, isn't it?
I think it technically is, but
How do you know when it's a triple?
when it's just nice, like when it's like nice
Whole
and
numbers.
yeah.
Happy little whole numbers.
Like there's one that's like 5, 12, 13 is one. 3, 4, 5, and 5, 12, 13 are the most common ones that I know. Like they're the ones that I like know off the top of my head. The other ones, it's just yeah. But if they end up being nice, pretty whole numbers, and they are.
So how do we know that for the first one it was 3, not 6?
Because the hypotenuse is the longest side.
Oh, okay. Okay, that's what I was thinking, but I didn't know.
Well, it was more so because it was a Pythagorean triple that we just threw it on there. But it would have been 5 squared minus 4 squared, and the square root of that. So 25 minus 16 would be 9, and the square root of that is 3.
Okay.
So, yeah. So you can do it that way, or you can just write it down either way. So then this is what I do, because these problems are asking you things like the cosine of a plus b, the tangent of a minus b. Okay, that's what these kind of problems are. So what I go through and do, because in our formulas, all we care about is sine, cosine, and tangent values. So I go through and I write each of the trig functions of each of these angles. So, like, I will not do secant, cosecant, and cotangent because I don't need them. So, sine of A would be what for this one?
3 over 5.
3 over 5. Cosine was given to us, but I still usually go ahead and write it just so that it's there. Tangent of A is
3 over 4.
3 over 4. And then I do the same thing for the other one. So sine of A, or sine of B, sorry, was given to us, negative 15 over 17. Cosine of B, 8 over 17. And then tangent of B,
Negative 15 over 8.
yep. So now when we're still going to set up the formula, but now what's going to happen is we'll just take those values and those are going to get plugged in. So in a sense, this is a little easier mathematically than the other problems because of this, because things are going to cancel pretty nicely because of how this works.
What's WSA? Where it's a WSA equals 4 over 5.
Oh, that's cosine. That's a CO.
Right here?
Oh, in the middle in the blue. Okay.
I was like, that's cosine.
Okay.
I was like, what?
So much like a W.
I was like, what is happening? Okay, so we're using this information, so we may have to scroll a little bit. Well, I'll have to scroll. You'll probably just have it there. But 12 is asking for the sine of A plus B. So what's the formula for the sine of A plus B with the A and B being the letters in it?
Sine A cosine B plus cosine A times sine.
So then all we do now is plug in this information. So sine A is 3 over 5. Cosine B is 4 over 5 plus cosine, or wait, nope. Cosine B is not that. Cosine B is 8 over 17. Look at two sets of information. Cosine of A is 4 over 5. Sine of B is negative 15 over 17. So then this is, let's see, 24 over, well, it's going to end up having a common denominator since they're both over 5 over 17, or 5 times 17. 5 times 17 is 85, and 4 times 15 is 60, and it's going to be negative. So 20 minus 60 on top over 85, so that's going to be negative 36 over 85. So once you set it up, it's literally just algebra, and if it doesn't have a common denominator, getting one. But because of how this falls, usually it has one. So All right. So tangent obviously is still going to be a little bit more difficult. So let's look at that one. So tangent of A plus B. And I say more difficult just because it's obviously always going to be a fraction. And by default, a fraction and a fraction. So formula for tangent is what?
Tangent A plus tangent B over 1 minus tangent A times tangent B.
Yep. So then, see, plugging this in, tangent of A was 3 over 4. Plus tangent of B was negative 15 over 8. All over 1 minus 3 over 4 times negative 15 over 8. So then we need to still get a common denominator like we do like in general. We need a common denominator on the top, and then once we do some multiplication, we'll need one on the bottom as well. So what would I need to multiply this by?
2 over 2.
Yep. So I'm multiplying this by 2 over 2. So on top, I have, that's going to be 6 minus 15 over 8. All over 1 minus, oh gosh, that's going to end up being plus because of the negative and the negative. It's going to become plus. 30 times 15 is 45 over 4 times 8 is 32. So I need to get the common denominator here with the 1. So I'm multiplying that by 32 over 32. So that's going to give me, I'm going to just write this off to the side here. That's going to give me 32 plus 45 over 32. So then now 6 minus 15 is negative 9 over 8. All over 32 plus 45 is 77 over 32. So now what? That I have the fraction over the fraction.
We can do the keep, change, flip.
Yep, keep, change, flip. So negative 9 over 8 times 32 over 77. So 8 and 32 reduce. 32 becomes a 4. I don't think so either. So then this becomes negative 36 over 77. So tangent's still a little weird, and some of these, like those middle steps, if you feel like I can skip those and like I still know what's happening, that's fine. Or if you do some like little math like this where you like put it out to the side to just show like what's going on to save you having to rewrite everything and take up like literally an entire page of paper, that's fine too. So, and if you like to write like sideways instead of stacking it, that's also fine. Any questions about that one? I know tangent's usually more confusing, so pause if we have a tangent question.
Could we at the top where it's like, right there, where it's 3/4 plus negative 15 over 8, could we just write 3/4 minus 15 over 8?
Yeah, yep. I only did that just so that you see the formula, so if you go back, you don't like mix up the formulas in your head,
Yeah.
but I don't remember, because I'm teaching this in 2 classes right now. I don't remember if I told you this or not yesterday, but what I will do is on the quiz for 14.6 and 14.7, I will allow you to do like the cheat sheet thing like we did before, and then on the test, I'll probably just let you have the whole cheat sheet with everything on it.
Yeah, I think you told us that yesterday.
Okay. When I'm teaching the same thing in 2 classes at the same time, and I'm about to be teaching it in 3, it's like brutal. So
What's the third
like
class?
college algebra, because they get a lot of trig. Because it's basically Algebra 3 with trig.
Oh.
So it's like, that's like how I would describe the class when people ask me what it is.
So like this class on steroids.
Yeah. It's like a weird mix of this class and pre-cal. Like, not as hard as pre-cal, but
A little
harder than this.
Yeah.
And there's like some things that, because all of them have actually had, well, all of them have already had trig, so I'm teaching it as if they've seen it before. But in the future years, like the people coming out of my mom's class or like Miss Marshall's class, like that end up with me in college algebra, I will have to teach it knowing that they've never seen it before. So like I'm teaching it to you. So like, for example, like Janixa had not taken this class, so she didn't have any trig, but she had to go into pre-cal because of the scheduling issue. And so like I told her, I said, if you're confused, go find my Algebra 2 videos because it will be more explained than,
what we're doing right
yeah. So,
I feel like that's probably gonna be like Tori and William. I feel like by the time they come back up with us, I think they'll probably be in college algebra with us.
well, so like you probably won't take college algebra.
Oh.
College algebra is meant to be taken as a stepping stone for people that took Algebra 2 that want to take pre-cal. Because you can't go into pre-cal without having. Now, it's going to be, pre-cal's going to be AP next year, or have an AP option. It's going to be taught as one class, but I would highly recommend you doing the AP test, because you could get out of a college class, and all of you would be fine. But that's the plan, is it's supposed to go AP next year, meaning we cannot tell someone they can't take the class. Currently, the way we teach it, we can say, you haven't had trig, you can't take it.
Yeah.
So, unless it's like a scheduling conflict or something. But like, I would not recommend coming out of my mom's class or Miss Marshall's class that you jump straight into pre-cal, especially not AP.
Yeah.
Because I have to fly, like, to get the material in.
Yeah.
So, I wouldn't recommend it for them.
Yeah.
I would wait and tell them to take it their senior year, take college algebra next year to get that stepping stone class. But, like, for example, like, it's Hope and Ethan and Lorelai. So, like, Hope and Lorelai are taking college algebra for the fact of, I need to get a refresher before I go to college and take that entrance exam.
Yeah.
Because if I get a refresher, I probably won't have to take any math in college for the degrees that they're pursuing.
Yeah.
Ethan has already had pre-cal, could have been taking calculus this year, but we had already decided to not offer calculus because nobody was taking it by the time he enrolled.
Yeah.
So we were like, we'll take this in the meantime, and he's taking stats. So next year he'll be back with his class in. But by taking that, he's not sitting out of math for a year.
I keep forgetting that he's a junior.
So, yeah.
I got told don't take any AP classes by Miss Patton because she was like, you missed so. At first, I thought it was saying she was telling me I wasn't smart, and she was like, it's just because you missed so much school. And I was like, okay, that makes sense. But I feel like
You
when
didn't
we
really
go,
miss that
because
much this
is in
year,
the
though.
morning- Well, last year when I
Oh.
was missing a lot of school because like sickness and then traveling and all that.
Yeah.
Yeah.
All right, what's our formula for cosine? For the minus one.
Cosine A times cosine B plus sine A sine B.
So then cosine A was 4 over 5. Cosine B was 8 over 17, right? Was that negative or was it? No, it was positive. Okay. Plus, I'm trying to look at my paper here, but some of the stuff is cut off on it, so I'm like trying to see what it was without having to scroll every time, but I thought it was a negative sign, so if it is, just yell at me if I don't have it. 3 over 5 is sine of A, and sine of B was negative 15 over 17. Is that right? Is that what y'all had? Okay. So, I can tell this is all going to be one fraction, so just to save a step of writing, I'm going to go ahead and do that. So 5 and 17 is 85. Then 4 times 8 is 32 plus, or well, it's going to end up being minus. 3 times 15 is 45. And so then that becomes, what, negative 13 over 85. All right, so there's a little bit more to this section, But I'm going to wait and do this tomorrow and then give you, probably just tomorrow will be a work day. And then what I may do is just give you the formulas, or if I can find my notes video for the formulas next week, I'll have you watch the formulas for 14.7 with the worksheets that I give you, and then we'll use the stuff from 14.7 when I get back. So the problems so far, if you want to start, are, well, I may go ahead and give you all of them, but just know that like the last 3 you won't be able to do. 3, 7, 13, 15, and 19. Oh, wait, and then 23 and 25. I think 19 is one that, 19's in the stuff we haven't done, which if you really put your thinking cap on, you would figure out 19 through 25, not a problem, but you can just wait till we go over them tomorrow. They're really easy.